the next one we're going to do, let's open up another tab here, is going to be the nut. So go ahead, we'll pick any one of the planes that you like. We'll go here, get that arranged the way you like it, and then come down here and find your polygon tool. And I'm going to go ahead and click right smack in the center, bring this out like so. I like to usually bring this straight up because you see this line. I didn't mention this before in any time we've talked about making nuts, I don't think, but you notice how it snaps to the vertical right there or snaps to the horizontal. It gets rid of 1 degree of freedom that I don't have to sort out later. So it'll snap right to there. And now I could still shrink it, but I can't twist it. Okay, so we're going to measure from flat to flat here. That is typically what makes the most sense because this is going to be a nut and there's going to be a wrench that goes on this, and the wrench and the nut are named by this distance right here. So it's a 1.25 wrench. Here, let's go take a peek at that real fast. 1.125, so 1 1/8 inches. Okay. There are some cases where I've done some things where I need to have it to be this kind of basically the diameter of this outer circle or from point to point, but that was some odd cases. Normally you're going to make a hex nut, the width match the wrench that's going to be used with. Okay, so we'll exit out and we'll pad this up 0.4 inches, just like so. And then I guess we'll put the hole through here. So again, you know, you could put the hole on this face, or you could go on this face, or you could go on this plane. Continually think about that, which is going to be the best way to do this. Flip that around. And again, we're going to make this dimension 0.75. Exit out, extrude this through, pocket, up, through, up to last. Okay. Now, the last little bit that we're doing on these nuts all the way, all the time, is we're adding this little bit of bevel that goes around the outside here. And I thought I should talk about this a little bit more. It is pretty common on all the nuts. For the modeling to be dimensionally accurate, for you to look at your pulley over here and see if everything's going to fit, it doesn't necessarily have to be there. And you notice on this one here, I decided to just add it on one side, and that's, you know, kind of just a choice because I've seen nuts that fit and sit this direction here. Yeah, let's pause that. Now, typically when we're designing nuts, us specifically in these courses, we end up adding this chamfer that goes around here. And I thought I would like to talk a little bit more about what we're doing here and why we're doing it. So first off, the why, it's basically because that's the way it comes out when it's manufactured, and we want it to look that way. Dimensionally, I can't say that having the chamfer here or not has affected my fitment of anything. I haven't built a product and went, oh man, it's off by, you know, so much because I forgot to put the chamfer on the nut. So it's not anything to do with actually the dimensional accuracy of the entire assembly. So it's mostly about looks. Now, getting past that and saying, okay, well, how do we want to make it then? If you look at this, they're pretty much all the same. You see that we've got this circle right here that's touching the flat walls. So if you think about it, the diameter of that circle is the same as the width from flat to flat, what we did previously. So it's 1 1/8 inches. Now, this next part here, I'm going to take this opportunity because it's such a simple part to explain in a little bit greater detail why we do things a certain way. For example, why did I pick the plane that shows me the longest side from this side right here to this side right here of the nut, as opposed to going on to this plane that shows me it this direction? Why did I choose that? So let me hit normal view to flatten me out. So what I want to do is I want to make a little triangle over here that's going to make the chamfer. So if you recall, we make a little triangle and then we use the groove tool to spin it around the central axes to cut that chamfer for us. Now, what we just looked on the diagram, when we spin this around, it remember the circle that I was just showing you on the inside here that's the same diameter as from flat to flat. If I draw my triangle the right size here, it will spin around and essentially cut nothing right here, and then start cutting just these corners off. Okay. If I look at it from this side, I need to make some construction lines. So this is also a talk on construction elements. So let me draw this, and then hopefully this will begin to make more sense. I'm going to draw a line on here, on that horizontal line to right over here. Click, and I'm going to make it a construction element. So I've got a dashed line. I'll tip it down so you can see this. Now, I'm going to click this point here, and I'm going to hold down Control. You don't have to do this, but this is the way I do things sometimes. I'm holding down Control to pick the 2 points, and then I hit Constraint, and it gives me my dimension. A little bit different way to do it than you see me do it normally. Before I click, I'm going to right-click and choose Allow Symmetry Line, and get that vertical line right there. So what I've just accomplished now is making this line be symmetrical right across that center vertical. Great. Now I'm going to dimension it, because this is my guide. I'm going to dimension it to 1.125. So now this is the same width on the long side. So I'm on the sketch plane with the long side of the nut, but this is the same length as it is from flat to flat. So now I'm going to, how about I'll draw the triangle out. Make sure you don't accidentally stick to, watch out for your auto constraints. I probably don't want this right at this moment, but I want to bring it out here for explanation. I want this to be right here. I want that point touching right there, and I want this flat touching right there, because that's going to define, the triangle that I'm going to use to cut that corner off. Now, if you think about this, if you do this and you kind of, wonder why I picked the long side, let me exit out and show you this. I know right now how long it is from flat to flat, 1.125. I don't know how long it is from point to point across here. I absolutely could measure this and it would work fine, but maybe I just plain don't want to. So if I were to pick this plane right here and go into Sketch, this distance from right here to here, I could project these out. That distance is 1.125. That's the flats. So I would have that line that I just drew already. I wouldn't have to draw it. I would have the projections right there. What I would have to draw, though, or measure, oops, that's what happens when you don't set your axis system up right. The little bit of the sharp, the longer side there, I'd have to figure out what that is to get the triangle stuck to it. So again here, if I just tip it up like this, here's the long side. If I'm looking at it from the short side, the end of my triangle I need to have measured to that long section. Okay, so let me go back to the sketch and say something here. This is why I want to be on the long side, because now that I've measured out the value I do know, 1.125, and put my construction line there, now I can pick this edge right there, project that forward as a construction element. I didn't have to measure. This is the length I was talking about. I don't know what this is from edge to edge. And so without having to measure it, I go on this side, I project that out like this, and now, here, watch, I'm gonna get rid of this triangle. I'll just redraw it. Now that I have this as a guide, that point there as a guide, it becomes a lot easier for me to come in here and pick that point there, drop down here, go right there, and there's my triangle. It's all perfect because I have these nice guides right there for me. I didn't have to go measure too much. Now, for the last part of this, the depth, we do have to kind of guess at that. So we'll go here, we'll pick this, and how about we say 0.05. That might be too much, but we'll roll with it. So I hope this little side journey here gives you something to think about as you're making your parts and you're choosing which plane to go on. Try to do your best to think a step or two or three ahead of what you're doing to try to make the smarter decision. Okay. So we'll go ahead and we'll exit this out and we'll get this nut finished. So there's that part right there. Come down here to groove. It already picks the sketch because it was already selected. I'll hit the axis system. I'm picking this side edge here, which gets the cylinder, and we'll spin that around 360 degrees, and then we have it.